बिस्मिल्लाह। अच्छा जी, स्टार्ट करते हैं। लास्ट लेक्चर में हमने स्टार्ट किया था Petri nets. Petri net is a kind of graphical modeling tool that we can use for modeling and simulation of physical systems. और हमने पढ़ा था कि a Petri net is composed of places. A Petri net is composed of places, tokens, transitions, and arcs. Or places contain tokens, where token is a kind of permission to perform some task, and tokens move from one place to another. Tokens move from one place to another by firing transitions. So ऐसे होता था. So by firing transitions, tokens move from one place to another. Tokens are contained in places, and tokens move as a result of firing transitions. तो a transition can be, ये भी हमने पढ़ा था कि a transition can be enabled or it can be fired. For example, अगर ये एक transition TI है और इसके साथ कनेक्टेड है एक प्लेस जिसके पास एक टोकन है, तो this TI is enabled. This is enabled. लेकिन अगर इसके साथ दो प्लेसेस कनेक्टेड है, इसे हमने लास्ट टाइम एक एग्जांपल पढ़ी थी जिसको हमने पाइथन में सिमुलेट भी किया था, तो ये इनेबल्ड नहीं है अनलेस कि इसके पास भी टोकन हो। और अगर इसके साथ 3 प्लेसेस कनेक्टेड है तो फिर तीनों के पास, तो हमने ये पढ़ा था कि इनके दरमियान में एक लॉजिकल एंड है। और फायरिंग का मतलब ये है कि once this transition has fired, suppose it's connected to one output place, the token is fired, the transition is fired, and you will find this token now at this 4th place. Or token from all these 3 places will be consumed. So after firing, after TI is fired, TI is enabled. TI is enabled. After TI is fired, you will find your token here. तो हमने देखा था कि आप किसी पे, जब मैं फर्स्ट एग्जांपल की थी वो किसी प्रोडक्शन और डिलीवरी सिस्टम को मॉडल करती थी, सप्लाई एंड प्रोडक्शन सिस्टम को मॉडल करती थी, और काफ़ी सारी प्रोसेस देखी थी। और हमने ये भी पढ़ा था कि वी कैन ड्रॉ अ रीचेबिलिटी ट्री और we can also draw a reachability graph. इस तरह की भी कुछ चीज़ें पढ़ी थी, reachability tree और reachability graph भी पढ़ा था। reachability graph का मतलब ये था कि फॉर एग्जांपल, और हमने मार्किंग्स भी पढ़ी थी और ये सब मार्किंग के बेस पर है। ये दोनों रीचेबिलिटी ट्री एंड रीचेबिलिटी ग्राफ, दे बोथ आर drawn on the basis of markings. Marking is the state of your network, state of your PN. You also call it PN. PN stands for Petri, right? So marking is something which is called the state of your PN. For example, if you have this PN having two places P1 and P2, and you have a token here, and this is the only transition in the network T. So the marking, one possible marking is for this network is 1 0, showing that you have one token at place P1 and no token at place P2, or it can be 0 1. So there are two possible markings for when this transition is fired, this token is consumed, this P2 gets a token. So the second marking is this. So we can also assign them names, like for example, this is M0, this is M1. So we can have markings, we can give them names. Marking is the state of your network. Marking is the state of your network at any given time. And actually, this represents the presence of tokens. Marking represents the arrangement of tokens after a certain sequence of firing transitions. You get marking. You can get different markings: M0, M1, M2. You can give them names, and a reachability tree is drawn on the basis of markings, starting from some initial position. And reachability graph is based on reachability tree. This is what we studied last time, and we also studied incidence matrix I. Incidence matrix IM. Incidence matrix, जब हम ड्रॉ करते हैं incidence matrix, when we write contents of elements of incidence matrix, we assume that every transition is enabled. Last time पूछ रहा था कि when you write IM incidence matrix, for example, for this PN, so you write it like this: P1, P2. It can be otherwise. You can have places as columns and transitions as two rows, or it can be like this. You can have transitions as columns, places as rows. So if you fire this transition, and when you write this column, you assume that this transition T is enabled. Even last time we बताया था. You'll assume that this transition T is enabled. So you have to write, but when it is fired, what would happen? A token would be consumed from P1 and would be added to P2. And if we have a Petri net like this, मतलब ये हमने last time पढ़ा था. If you Petri net like this, there is another place P3, another transition T2. Now we'll have to write a T1, this as T2. तो जनाब ये हो गया T1, T2. So when you fire transition T1, this means this is enabled. So we'll assume this is enabled. And when it is fired, one token will be consumed from P1 and will be added to P2. And once you have written this column, and now you're going to write this column for T2, you'll assume that everything is set for T2 and T2 is enabled. And you'll forget everything what has happened before. So forget any past. Forget anything happened in past. In past, I mean, forget anything that you assumed while you were writing the first column. So in this case, forget anything that you assumed while you were writing. column 1, the last column. So you have to forget everything. Now you'll assume T2 is enabled. What has happened before when you were writing this column number 1? Just forget that. Just forget that. Forget anything that has happened before, that has happened in the past. So आप क्या assume करेंगे? You'll assume that when you're writing this column, तो आप क्या assume करेंगे? क्या assume करेंगे? You'll assume that everything that has happened while I was writing T1, I have forgotten that. So now let's assume that T2 is enabled. If T2 is enabled, one can assume, and if T2 is fired, T2 is enabled, and if T2 is fired, one token will be consumed from -1 from P2 and will be added to P3. So we have to add another row क्योंकि now we have this third place. So क्या करना पड़ेगा? We have to add this third row. So P3 is the third row, and when we were firing transition T1, this remained unchanged because this P3 neither gets a token nor it loses a token when you fire T1. So you'll add a 0 here while you're firing T1. And if you fire T2, this P3 gets a token, therefore I add a +1 here. This P2, it loses a token, therefore I write a -1 here, and this P1 remains unchanged. So it's not connected, therefore I'll write, what should I write? 0 here. ठीक है जी, तो हमने 0 लिख दिया because it remained unchanged. अच्छा, ये भी हो सकता है कि if I extend this network to a bigger network like this, let's call it T3. तो अब आपके पास ठीक होगी चीज़ें. T1, this is T1, T2, and T3. So what should your IM look like now? Because you have added another transition T3, so there must be another column added, T3. So now you can complete it by writing this third transition. Then if T3 is fired, this P3 loses a token, this P3 gets a token, but your P2 neither gets a token nor it loses a token. It remains unchanged, therefore I'll write it. P2 is equal to P2 in P2's row. I'll write a 0. This one. ठीक हो गया जी. So let's move on to the next example. Actually, last time when we ended up, we were studying reachability tree and reachability graph, and I told that while you start drawing reachability tree, it's another recap. That when you start drawing reachability tree, RT, let's call it RT, reachability tree. While drawing, I should write it like this. While drawing RT, reachability tree, you must have some initial markings. So without initial marking, you cannot draw RT. You must have some initial marking. Marking means state. So initial marking is mandatory, ज़रूरी है to have this, to draw this RT, reachability tree. But to write the contents of or the elements of this IM matrix, incidence matrix, we don't need incidence matrix. We don't need that. We don't need any initial conditions. We write one column, and while we are writing one column, we forget everything that has happened in the past, or everything that is going to be in the future. ठीक है? तो when you write any column, you forget everything from the past. तो ये तो IM हो गया. तो अभी तक recap चल रही है. So while drawing RT, you must have some initial markings. Let's say, for example, if you are given this network, so you must have some initial marking, right? For example, this Shiba token here, and then you can start the network. And of course, this initial marking should be such that you can start the network. So this can be written as, now we have 3 places, P1, P2, and P3. This initial marking can be written as 1, 0, 0, and as, और हमने last time क्या पढ़ा था? This initial marking can be can be written as 100 and given this initial marking 100, let's give it a name M0. M0 the initial marking. So if we are in this state, we can only fire T1. Actually, we cannot fire T2 because T2 isn't enabled. P2 doesn't have a token, and T3 is also not enabled because P3 should have a token. I mean, it must have a token in order for T3 to be enabled. Since we don't have tokens here, therefore T2 and T3, आपको पता है कि T2 and T3 aren't enabled. Only T1 is enabled because you have a token here. So at this state, we can only, or at this marking, being at this marking, we can only fire T1. And if we fire T1, there is some movement of tokens. For example, T1, this token is consumed from P1 and it is available here in P2. So, and of course, it's a different marking. So let's assign a different name, 010. So it's a different marking, right? And once we are at this state, only T2, we see only T2 is enabled. So only T2 can fire. So if we write it as T2, so we move on to another location, M2, and that is another marking M2. Let's call it M2 because it's also going to be different from both M0 and M1. So we have to assign a different name, right? And now only T3 is enabled. So let's fire T3, and as soon as T3 is fired, this token is consumed, and this is now available, and the token is available now in P1, and now the state is, or the marking is 100. But fortunately or unfortunately, this isn't a unique marking. This is the place we started with M0. So going any further would be useless because the next step would be this one. So we'll be able to fire only T1 and then we'll get M1. So that would be repetition of what we have already implemented in this graph. So going any further would be of no use, would be useless. So this graph is RT, reachability tree graph, that we studied last time. And given this RT reachability graph, आपको पता है हम क्या करते थे? We would draw reachability graph. पता है ना आपको? Yes, we would draw a reachability graph. RG आपने बनाया हुआ है last time. This RG isn't RG can only be constructed if we know all unique states, all unique markings or states, all unique markings of the given network, number one. ठीक है जी, ये पता होना चाहिए ना कि what are the given markings of the given network, ये पता होनी चाहिए, ये आपको पता होनी चाहिए कि what are all possible markings. एक बात आपको और भी पता होनी चाहिए, and that should be how do you move, how do you move from how do you move among these markings? How do you move among these markings? So if you know this information, what are the unique markings and how do you move among these markings, you can draw this RG, the reachability graph we studied last time. So given this information about the network I've just erased, क्या होगा इसके लिए? This should be an M0 is a unique state, M1 is a unique state, and M2 is a unique state. This M0 isn't unique because this M0 is indeed the same as this M0. So we can move from M0 to M1 by firing transition T1, and then from M1 to M2 by firing transition T2, and from M2 we can only go to M0, this one. So it completes a cycle by firing T3. So it completes a cycle. Every marking is reachable from every other marking. Any MI is in the reachability set of mj, any other mj, where I is not equal to j. So mi is in the reachability set of, mj. So every marking is in the reachability set of any other marking mj, given I isn't equal to j. This means if you put m0, mi, for example, is equal to 0, and mj is equal to 1, this means m0 is accessible from m1. m0 is accessible going to m2, and then we can reach to m0. So either directly or indirectly, it's reachable. So every mi is accessible from every mj. तो ये हमने पढ़ा था last time. This was about our t and our g reachability. तो ये हमारी complete हो गई recap था. This completes our recap. अच्छा जी, अब थोड़ा सा आगे चलते हैं, और हमने लास्ट टाइम कहा था कि हम आज के लेक्चर में पढ़ेंगे, विल स्टार्ट विद सम एग्जांपल्स. We'll start with some examples, some more interesting examples, and we'll draw reachability trees and reachability graphs. Right. So I have another interesting example, that is, and then we'll study P invariant and T invariant. So today's plan is, what is today's plan? क्या है आज का प्लान? ये तो थी recap of the last lecture. आज का प्लान क्या है? आज का प्लान है छुट्टी करें. नहीं, छुट्टी नहीं करें. Today's plan is to solve two more examples from RT and RG, reachability tree and reachability graph, and of course we have to implement. We'll also implement their IM, the incidence matrices, and then we will study some properties, for example, T invariant and P invariant properties. And then we'll study stochastic PNs, stochastic Petri nets. So ये आज का प्लान है. ठीक है. तो or of course Python simulation, some Python simulations regarding stochastic Petri nets, SPNs. ठीक है जी, ये आज का प्लान है. तो another example from RT and RG continued. तो एक और इंटरेस्टिंग एग्जांपल है to understand कि how can we use this technique, क्या नाम है टेक्निक का, Petri net. How can we use this technique Petri net to real world examples. मतलब आप कैसे मॉडल कर सकते हैं. So it's an effort to convince you that Petri nets, it's a technique to model real world examples, and it can indeed model real world examples. तो ये आपको कन्विंस करने के लिए. So we'll start with an example we call a dispensing machine. Dispensing machine is a machine that gives you a Coke. Suppose करने के Coke is of ₹20, 20 रुपए की है. So if you have coins, for example, as coins हैं, you have coins like 5 rupees coin, a 10 rupees coin, and that's all. So you can buy this 20 rupees Coke like 5 plus 5 plus 5 plus 5. I mean, by putting 4 coins of 5, of course, that makes 20. Or you can buy like 10 plus 10, it's also 20. आपके पास 10 रुपए का कॉइन है, you put first coin first and then the second coin, तो भी आपके 20 रुपए हो गए. And or you can start from 5 and then 5 and then you see you have a 10 rupees coin, तो फिर भी आपके 20 हो गए. or we can start from 5 plus 10 plus 5, ऐसे भी हो सकता है, तो ये भी 20 हो गया. अच्छा, ये भी हो सकता है कि 10 plus 5 plus 5, ऐसे भी हो सकता है कि you have 10 rupees 10 rupees coin first, you put 10 rupees coin first and then a 5 rupees coin and then a 5 rupees coin. तो different combinations. I hope ये सारे combinations हैं. अच्छा, तो ठीक है, तो you can model this dispensing machine, the operation of we can model the operation of this dispensing machine using PNs, using Petri nets. तो Petri nets को यूज़ करके आप मॉडल कर सकते हैं the operation of this dispensing machine. ठीक है जी, तो बना लेते हैं Petri net. We already know how to draw Petri nets. We already know how to draw Petri nets because we know the Petri nets have places and they have transitions and they have tokens. So when we start, we'll start from the first place where the machine has received none, I mean 0 rupees. So let's first draw a place and call it P1, and this corresponds to 0 rupees, right? So if we put this 5 rupees coin first, for example, you will get this, you will reach to this P2. This corresponds to his 0 rupees. This P2 corresponds to 5 rupees, and let's call this transition as T1. And if you put another 5 rupees coin, then you reach to another place. Let's call it P3, and you reach to P3 by firing T2, and that place is, it corresponds to 10 rupees. We'll erase these duplicate representation of these places because now they correspond to I mean it's easier for us to represent these states in terms of rupees, because why it is easier and why I have given a duplicate name to P3, because once I was at this initial place, I could directly go to P3 by inserting a 10 rupees coin. So therefore I have written a 10 here, because that is why I have written 10 here, because I could go to this 10 rupees state directly by putting a 10 rupees coin. That's logical. So I mean I have two ways to reach to this 10 rupees state, either by putting a 5 rupees coin first and then a 5 rupees coin, or I can go directly from P1, the 0 rupees state, to 10 rupees state by putting a 10 rupees coin directly. So these are the two possible ways to reach to this 10 rupees state, either by 5 and 5 or directly by putting 10 rupees coin. Right. So the next is I could have another place, and that we call it 15 rupees state, and I can reach to this 15 rupees place by T3. T4 by putting 5 rupees coin. And there is one other way of reaching to this state, this P4 state, that is directly from 5 rupees. That if I have 5 rupees, I would have put 5 rupees coin first, and then I would have put this 10 rupees coin. ठीक है, तो पहले आपने क्या किया, you put a 5 rupees coin, और फिर क्या करते हैं आप, then you put a 10 rupees coin and you reach to this 15 state 15 P4, फिर 15 रुपये हो गए ना, पहले 5 रुपये फिर 10 रुपये, तो then you reach to this 15 rupees state. So by reaching to reach to this 15 rupees state, you can either adopt this path 5 plus 10 or 5 plus 5 plus 5 path और 10 प्लस 5 पाथ. ठीक है, तो ये 3 पाथ ही बनते हैं ना, 5 प्लस 10 पाथ, 5 प्लस 5 प्लस 5 पाथ, 10 प्लस 5 पाथ. तो ये 3 पॉसिबल पाथ्स ही हैं. एंड देन वी हैव योर फाइनल स्टेट, द स्टेट क्या नाम थे उसको, P5 कहते हैं. P5 दैट कॉरेस्पॉन्ड्स टू 20 रुपया. दिस स्टेट कॉरेस्पॉन्ड्स टू 20 रुपया, 20 रुपीज़. तो यू कैन रीच टू दैट स्टेट बाय पुटिंग अ 5 रुपीज़ कॉइन. ठीक है जी. क्या नाम दें इसको, लेट्स कॉल इट T6. Oh, this T6 is the transition that when executed, when fired, you reach to this 20 rupees state, and it is fired when you put a 5 rupees coin when you were at P4, the 15 rupees state. ठीक है जी. उसके बाद क्या होगा, next you have to and to reach to the state 20, you could have come directly. ऐसे भी आ सकते थे आप, you could have come like this, ऐसे भी आ सकते थे. T6 T7 एग्जीक्यूट करके भी तो आ सकते थे ना. मतलब T7 is fired when you put a 10 rupees coin and you were at this state P3 10 rupees state. मतलब 10 रुपये प्लस 10 रुपया, इसका मतलब ये है 10 रुपये का कॉइन प्लस 10 रुपये का कॉइन, इसका मतलब ये है, राइट. एंड देन यू कुड हैव फायर अनदर ट्रांजिशन डिलीवर्ड T7 T8, and then you move to the 0 rupees state that the coke is delivered and I'm ready to accept another 20 rupees to deliver another coke. So this is how we can draw a Petri net let into a dispensing machine, a real world example, an example from your daily life. Starting from some initial state P1, you could either go to P2, the 5 rupees state directly, and actually it has only one way to go to 5, but to go to 10 rupees state, that is P3, we have two options. क्या क्या हैं, या 5 रुपया प्लस 5 रुपया, या फिर ये कि you enter 10 rupees coin and you reach to P3, right? And then when you are at state P2, when you are at place P1, so you could have reached to 10 rupees state by entering 5 rupees by firing T2, or you could go to directly the 15 rupees state by firing T5. ठीक है, तो आप 5 रुपये से 10 रुपये की स्टेट पर भी जा सकते हैं और 5 रुपये से 15 रुपये की स्टेट पर भी जा सकते हैं, और आप डायरेक्टली जब स्टार्ट करते हैं तो आप 10 रुपये की स्टेट पर भी जा सकते हैं. वंस आप 10 रुपये की स्टेट पर पहुंच गए तो देन यू कुड हैव मूव to the 20 rupees state by entering 10 rupees coin by firing T7, or you could go to 15 rupees state first by firing T4, यानी 5 रुपये का कॉइन डाल के, and then you enter another 5 rupees coin and then you reach to P5, the 20 rupees state. So similarly from 5 to 15 जाने के भी दो रास्ते हैं, either you could go from P3 to P4 or you could go directly from P2 to P4 by entering a 10 rupees coin. तो ये हमारा बन गया, ये बन गया कंप्लीट डिस्पेंसिंग मशीन का पेट्री नेट PN. जल्दी से आप IM लिख दें, इसके लिए इंसिडेंस मैट्रिक्स लिखते हैं. आपके पास 1 मिनट है. एक मिनट हो गया. तो P1 कितनी ट्रांजिशंस हैं, वी हैव T1 अप टू T8. ओहो पॉसिबल है. और कितने स्टेट्स हैं, 5 हैं. P1 P2 P3 P4 एंड P5. मैं ज़रा क्विकली लिख देता हूँ. T1 T2 T3 T4 T5 T6 T7 and T8, and if you fire T1 तो क्या होता है, suppose you started from here, oh sorry, if you fire T1 you don't have any marking, actually you neglect any marking. If you fire T1, a token is transferred from P1 to P2. You don't have to worry about the position of the tokens or the placement of the tokens. So if you fire T1, this means you will presume, you will initially assume that this transition T1 क्या है जी, it is enabled. This transition T1 is enabled. So don't worry about the placement of tokens. If T1 is fired, P1, a token is consumed from P1 and is added to P2, and all other remain unchanged. And if you fire T2, a token is consumed from here and is added here, and all other remain unchanged. So if I fire T3, a token is consumed from P1 and is added to P3. And you can of course complete this whole graph. This is your homework. This whole matrix. This is your homework. You can complete. But it's not your homework. If it is your homework, yes, it is your homework. Okay, it is your homework. So the remaining columns, writing remaining columns of this matrix is your homework. ठीक हो गया. तो अच्छा आगे चलते हैं और let's draw RT and RG for this network. RT ड्रॉ करते हैं for this network. RT ड्रॉ करते हैं. बहुत ही बड़ा काम है RT ड्रॉ करना, क्योंकि हमें काफ़ी सारा काम करना पड़ता है. कैसे? RT and RG is RT reachability tree. Let's draw reachability tree. And to draw reachability tree, आपको क्या होना चाहिए? मैंने शुरू में बताया था, you must know the initial marking. Suppose this is the initial marking, you haven't put anything in the machine yet. ठीक है, अभी तक आपने machines को एक coin भी नहीं दिया. ठीक है, तो आप यहाँ पर हैं. तो suppose कर लें आप यहाँ पर है P1, तो we have 5 states. तो इनिशियल मार्किंग को कैसे लिखूँ? 1 0 0 0 और 0 ऐसे लिख देते हैं ना, and 0. You have a token at place P1 and you don't have tokens from P2 to P5. They are 0. अच्छा जी, अब क्या करें? Now we have two transitions enabled, T1 and T3. Given to be at this state, क्या है जी आपके पास? You have two transitions enabled, namely T1 and T3. If you fire T1, the token is moved to P2. The token is moved to P2, and your new marking is 0, 1, P3, P4, P5. Since this is different from this marking, तो आप क्या करेंगे? It's a unique marking. You could call it a unique marking. You'll assign a name to it. For example, M1. अच्छा सा नाम रखते हैं इसका कोई. ठीक है, जिमी रखते हैं. जिमी नहीं रखते हैं, M1 रख देते हैं. ठीक है, T3. T3 is also enabled. If you have a token here, T3 is also enabled. And if T3 is fired, P3 gets a token 0 0. ये P3 है, P4 and P5. तो ये बन गया. And since this marking is also unique, तो कोई अच्छा सा नाम दे दें. इसे क्या दें? जैकब देते हैं? नहीं, M2 दे देते हैं. तो नाम थोड़ा मतलब ऐसे होना कि M0 M1 M2. ये कोई बच्चा थोड़ी है कि हम इसको नाम दे दें. तो इट्स अ मार्किंग. तो ठीक हो गया जी. हमने मार्किंग को अभी तक बड़े अच्छे नाम दे दिए हुए हैं. लेट्स मूव अहेड. एंड इफ यू फायर व्हेन यू आर एट M1, मतलब आप यहाँ पर हैं, इस मार्किंग पर हैं, तो नाउ यू हैव टू ट्रांजिशंस इनेबल्ड, एक T2 और एक T4. ये बड़ा कॉम्प्रिहेंसिव ग्राफ है. T2 and T5, ये दो मार्किंग्स इनेबल्ड है. ये दो ट्रांजिशंस इनेबल्ड है. तो इफ यू फायर T2, you reach to this state where P3 has a token. Only P3 has a token. मतलब अगर T2 फायर हो जाती है तो only P3 has a token then. तो ये मार्किंग बन गई 0 0 1 0 0. And this marking, fortunately or unfortunately, this marking is not unique. ये पहले भी आई है एक दफ़ा. Isn't unique. This is M2. so we don't have to assign it a different name. It's the same as M2. And if you fire T5 while being the token, while the token was in test P2, and you fire T5, your token is transferred to P4 from P2, and your new marking is 00010. This is the unique marking. Let's give it a unique name to M3. Right. Either we can move further from M2 onwards, either we can move from here or from here. दोनों जगह से फायदा नहीं है. Otherwise that would be a repetition. So if you have M2 here and you get an M2 here, so either you move further from here or you move from here. दोनों जगह से फायदा नहीं क्योंकि एक ही बन जाएंगे नीचे. So let's move further from here. We have this P3, right? We have a token here now, M3 at P3. This is state M2, and from here we can fire either T7 or T4 or T7. And if you fire T4 तो क्या होता है? And if you fire T4, the token is moved here. We have a token at place 4, this one, 00010. So it's also not a unique marking. It's M3. It's also not unique. And okay. And starting from this, if we fire T7, we get to a unique marking where only P5 has a token 00001. So it's unique marking. And of course we have to assign this marking a name. Let's call it M4. Right. So, and from this marking 4 and this 4, so either we stopped it earlier because we moved from M2, we moved further from this point, therefore we blocked it. And we have this M3 again, so we have to block any one of them. Oh, okay, let's block it. You can block it either. You can block it you can block this M3 or this M3, आपकी मर्जी है. So मैंने इसलिए इसको block किया because I don't have space beneath this M3, therefore I have stopped it. कोई ज़रूरी नहीं है, you could have stopped this. Okay, so from this M3 and M4, now we have to move further. From this M3, where we have a token here, where there is only one way. We can fire T6 and go to P5. From this, we can fire T6, and we could have go to another marking 00001. And even this marking isn't unique. This is M4. We already reached to this one. So now we have this M4. We could have blocked. We can block any one of them. And I think we should. We should block any one of these. आप इसको block करते हैं. So you could have blocked this. मैंने इसलिए इसको block नहीं किया क्योंकि I have a space beneath this marking to fire T8, the last transition. ठीक है जी, तो आपने ब्लॉक करना है. When you have duplicates M2, आपने क्या किया? आपने एक M2 को ब्लॉक कर दिया. When you had duplicate M3, you blocked one M3. Now you had duplicate M4s, you blocked one M4 of your choice.